Hello everyone, I am Hoong and here is my groupmate Nur Ain Shafiqa. We are here to present our manufacturing planning and control video assignment, which is talk about how the material requirement planning MRP works and how the inventory management works.
MRP is just like any other inventory management. And any inventory management, regardless of the level of sophisticated technology involved, essentially follows what's called the sawtooth pattern, where there's a certain amount of inventory that you start with, you use it up, eventually you get more, and do it again over and over again in this up and down pattern that looks like a sawtooth. There are these four discrete steps. You have an amount you're using up or expect to use. At some point, you reach a level of inventory that you've used up that you have to order some more at a reorder point. You might have heard the term min max at times. This would be your min before you want to run out that you order at. Then you continue to consume during the time that what you've ordered is on its way, and then you replenish. Usage, signal, continued usage, replenishment happens over and over again at Apple, Walmart, mom and pop, anywhere else. MRP is a variation on that. It balances supply and demand. It's monitoring what you're using, telling you when it's time to get more. It's just doing it in a specific way.
To summarize the previous explanation, material requirements planning focuses on providing the right part at the right time to meet schedules for completed products. And MRP uses information from the bill of materials, which is a list of materials, sub-assemblies, and other components needed to make a product, inventory data, and the master production schedule to calculate the required materials and when they will be needed during the manufacturing process.
So now, this is the basic concept of MRP, Material Requirement Planning. So in order to get more knowledge about the MRP, let's look into the lot sizing technique.
Now, let's focus on lot sizing techniques. Lot sizing involves determining the amount of item that needs to be manufactured. So, manufacturers need to balance the stock fulfill orders with the cost of inventory. How do they know how many units to create that balance? For example, Adam owns a business that makes furniture. If he makes too many products, he's stuck with a warehouse of inventory. If he does not make enough product, he won't be able to satisfy his customers. So, how can he make sure that he manufactures just enough product? Well, Adam can solve his problem by applying lot sizing techniques. There are 10 or more lot sizing techniques available, but let's focus on EOQ, POQ, and PBB. The first one is Economic Order Quantity, or EOQ. It is a type of fixed order quantity which determines the amount of item to be made or purchased at one time. There is a formula to determine the economic order quantity. In the formula, R is average demand, CO is setup cost, and CH is inventory cost. Let's say that the average demand is 50, setup cost $100, and inventory cost $1.5 per week. The EOQ will be 82 units. This means that Adam will order in 82 units every time he makes an order. Basically, the EOQ model aims to minimize storage and holding costs. It also provides specific numbers particular to the business regarding how much inventory to hold, when to reorder it, and how many items to order. Now, moving on to period order quantity, or POQ. POQ uses EOQ to calculate a fixed number of period requirements to include in each order. Dividing the EOQ, which is 82, and the average demand, which is 50, the POQ would be 2. This means Adam will order once every 2 months. POQ is simple to apply and the result is the same number of orders as EOQ, but with varying lot sizes and reduced carrying cost, which improves the total POQ cost compared to the EOQ total cost. Finally, the last method we will discuss, which is part period balancing, or PBB. PBB attempts to equalize the cost of ordering and holding inventory. For example, if the order is taken on week 1, the holding inventory would be $48.75. But if the order is taken for week 1 and 2, the holding inventory is $150. Since $150 is closer to the value of order cost, the order is taken for week 1 and 2. And the process goes on for the following weeks. Week 1, 3, and 6 are chosen because the value of holding inventory cost is close to ordering cost. Therefore, the part period balancing PBB procedure uses more information in the requirement schedule than other procedures. The PBB procedure allows both lot size and time between orders to vary. Now that we understand these methods, EOQ, POQ, and PBB, we must remember that discrete lot sizing procedures can reduce inventory costs, but the complexity shouldn't outweigh the savings.